This question asks how much heat is required to convert 45 grams of steam at 150 degrees Celsius to ice at negative 80 degrees Celsius. And we're given the heat of vaporization, the heat of fusion, and the specific heats of our liquid, steam, and ice phases. So I'm just going to start off by describing the equations that we need to solve this problem. And so we know that we need Q because the problem statement asks for heat. And there's two different types of heat that are possible. So we have sensible heat. And this is due to a temperature change. And our formula for Q in that case is generally Q equals M times C delta T, where C is our specific heat that we were given in the problem statement. And then on the other hand, we have latent heat. And this is due to phase changes. So in this case, our Q formula is going to be N times delta H of whatever phase change may be occurring, such as vaporization, heat of fusion. So for now, I'll just put PC for phase change. And in this case, I do have it in terms of moles, because if we look in the information given in the problem statement, our delta H of vaporization and fusion are given in per moles. So we need to multiply these terms by moles to get kilojoules. So now that we have that, I'm going to describe the process and what's happening in this case. So we start with steam at 150 degrees Celsius. And as we cool, we're eventually going to have steam at 100 degrees Celsius. And once this occurs, as we cool further, we're going to start converting into a liquid phase. And this is not accompanied by a temperature change. So we're going to transition to liquid at 100 degrees Celsius. And to describe this process, we're going to use the negative heat of vaporization, because the heat of vaporization describes transitioning from a liquid to a vapor. And in this case, we're transitioning from a vapor to a liquid. So now our liquid is going to cool to 0 degrees Celsius. And again, once we're here, we're going to experience a phase transition to ice at 0 degrees Celsius. And to describe that transition, we're going to use the negative heat of fusion. Similarly, because the heat of fusion describes a solid transitioning to a liquid, and in our case, we have a liquid transitioning to a solid. And then finally, we're going to move to ice at negative 80 degrees Celsius. And that is an outline of the process that's occurring. So now that we have that, I'm going to take a moment just to talk about units, because sometimes people know exactly the equations to use for this problem, but forget about how the units can vary so significantly. So based on our problem statement, we know that we need moles, and we know that we need kilograms in this case. So we're given that we have 45 grams of steam. So to convert that to kilograms, that's just 0.045 kilograms. We also need the number of moles. So we take our 45 grams and use our molar mass conversion to convert to moles. And I get 2.5 moles of H2O. And then I also want to note that while our problem statement gives us units in Kelvin, what we're focused on is the change in temperature. So the change in temperature can have units of Kelvin, or Celsius, because let's say you want to find delta T equals 24 degrees Celsius minus 48 degrees Celsius. If you want to find that exact same thing in Kelvin, that's just delta T equals 24 plus 273 Kelvin minus 48 plus 273 Kelvin. And these 273s end up canceling. You get the exact same thing in units of Kelvin. So if you're in a rush, you don't need to convert, although sometimes it's good just to convert every single time so you don't later on get mixed up because you don't have a delta T, but instead truly do need to convert to kelvins. But that's just talking about our units pretty quickly. And now what we're going to do is just plug in and solve. And so the first thing we have is steam going from 150 degrees Celsius to 100 degrees Celsius. So this is an example of sensible heat. So we start with Q equals our mass, which is 0.45 kilograms, times our 2.02 kilojoules per kilogram Kelvin, which is the specific heat for steam that we were given in the problem statement. And then we're going to multiply that by our change in temperature, which is just going to be 100 minus 150 Kelvin. And so now that we've done that, the second step in our process is moving from a steam to a liquid. So that is an example of latent heat. And that's going to be represented by adding our number of moles, which is 2.5, times our negative heat of vaporization, which is going to be negative 40.6 kilojoules per mole. And then after that, we transition to a liquid at 0 degrees Celsius. So again, it's going to be our mass, 0.45 kilograms, times the sensible heat of our liquid H2O, and times our temperature change, which is 0 minus 100 Kelvin. And the next thing we're going to do, similarly, is transition to an ice or to a solid phase. So that's going to be 2.5 moles times our negative heat of fusion. So that's going to be negative 6.02 kilojoules per mole. And the last thing we do is move to ice at negative 80 degrees Celsius. So we're going to use our sensible heat formula, which is our mass times the specific heat for the solid phase, and times our change in temperature. And I end up getting that Q equals negative 147.3 kilojoules.